Okay, here we go with a question about double slit interference, and we're looking at the effect of the color on an interference pattern. Have a go, and then we'll see how we get on. Okay, so here we go. This is definitely a question where you need to use a lot of data booklets. Okay, we're interested in the fringe separation, and so therefore we're looking for an equation to calculate that, and hopefully you found it, which is S equal to lambda times capital D over D. Quick reminder, S is the fringe separation, so we've got it in a form we like. Lambda is the wavelength of the light. D capital there is the distance to the screen, and small d is the distance from between the slits. And obviously we use capitals there because that's going to be the larger value, and small d than the smaller value. Now, why is this relevant? Well, this allows us to answer the question. The variable we are changing here is the wavelength. Okay, we're interested in the effect of wavelength here. And how do we know that? Well, if you had another little look in your data booklet, you'll have found this. This shows you how the wavelength relates to the color of light. You've got the whole spectrum here, and then down on the bottom, your red through to violet in terms of wavelength. Now, you may not have been aware that this exists. So if you have got an answer and you think, oh, hang on a minute, maybe I'm wrong, take a second to just sort of try the question again. If not, watch on to see an explanation. Now, we're looking at blue through green, yellow, and to red. Now, hopefully it's intuitive to you that we're really looking at either end of the spectrum here. One end is going to give us different spacing to the other. So we can immediately rule out a couple of answers, and that's those guys in the middle, green and yellow. There you go. I made an effort today of changing my colors. Green and yellow are out because they're somewhere in the middle. And this is a very common structure when you're having to make these choices, is that usually we eradicate the answers which are somewhere in the middle because they're going to give us answers which are somewhere in the middle. Now, we're interested in the largest fringe separation, so what we need to find is the largest wavelength. Now, you see here, wavelength of, well, we've got violet is the shortest wavelength, and then we've got blue here, which is the shortest in our range, and red, which is the longest. So I can actually get rid of blue because that is going to give me a shorter wavelength, all right? As the wavelength goes up, the spacing is going to go up. And so that means that the spacing of the red is going to be greater than the spacing of the blue, and we get rid of it, and we're left with red as our answer.